So today we're going to be looking at part 2 of graphing polynomial functions. So we previously learned how to decipher if a given equation is a polynomial or not, and how to evaluate it and to find the leading coefficient and the degree and all of that stuff. We need to now take that, especially our leading coefficient and our degree, to help us learn for part 2 what we call end behavior and our areas of increasing and decreasing. Okay, so again, this is all leading up to how do we actually graph a given polynomial. All right, so we're going to start with end behavior. So the behavior of a graph as x approaches positive infinity, so as it moves to the right side, and as it approaches negative infinity, as it moves to the left side, what is happening to the ends? So what is the left side doing versus what's the right side doing of our graphs? And in order to decipher that, we need to look at the degree and the sign of the leading coefficient. Okay, and again, if we think back to our quadratics that we just finished up with, we knew whether the parabola was up or down based off of the sign of our a term, our leading value. That's all we got to look at here. And what we're going to do is we're going to, no matter what the function is, no matter what its degree, we are always going to compare it to linear for odd functions and quadratics for even functions, because every graph that is considered odd is going to have the same ends as a line, as a linear function. One side is going to be going up as the other side is going down. Okay, I remember it by saying odds are opposites. ODD, OPP kind of looks similar. So I know the ends of an odd function will always be going in opposite directions. Okay, and we can kind of see that here. Whatever's happening in the middle, I don't care about that just yet. I care about what is happening on the ends. So if it's a positive function, it is similar to a positive slope, right? So if I was to draw a linear function with a positive slope, I know it's going in this upward motion here. One end starts low in the negatives, one end's going up high towards the positives. And if I flip it to make it negative, again, I can look at it. One end starts high and then it goes low on the negative side. Okay, so let me just erase that out here for a second. Now, what I have in the yellow boxes, that's how we're writing our end behavior. And this is what kind of tricks people up a bit. Basically, first we want to look at is we need one side approaching positive infinity, x approaches positive infinity, and one that's going to say x approaches negative infinity. And notice down here in these yellow boxes, I have that. I have one for the negative side, one for the positive side. That just means left side, negative, right side, positive. That's all we're talking about. We're literally splitting the graph in half. We're looking at what's on the ends of the left, what's on the end of the right. Now the top part, function notation wise, so it says f of x, so the function itself, the graph of the y's. Where are they pointing to? So in this first graph, when it's a positive leading coefficient that is odd, the graph points down on the left-hand side. So it's pointing towards the negatives. So f of x is approaching negative infinity as x approaches negative infinity. So again, on the left-hand side, my arrow is down. On the right-hand side, so that's where x's are positive, my graph is going up. I have an arrow pointing towards the positives on my y. So again, basically what I'm doing is I split it into two. F of x, remember, is just y. I'm saying where are the y's pointing to as the x's are on either side, whether it's the positive side or the negative side. Okay, oops, let's go back a second. So if it's negative, it flips it. On the left-hand side, my graph is pointing up in this case because the function is going in a downward motion. So it starts high, it starts up there in the positives. So the f of x is in the positive infinity range as x is approaching negative infinity, as x's are on the left-hand side. And then on the other side, now my graph's pointing downwards on the right. So the function is approaching negative infinity, it's going down, as my x's are on the right-hand side. Again, as you look at this, you're just looking at where are the arrows pointing? When you graph your function, or if you're looking at a graph of the function, where are those arrows on the ends of them pointing? All right, if they're pointing up, then the function is approaching positives. If they're pointing down, then the function is approaching negative. And you will always have an x approaching negative infinity and an x approaching positive infinity because you have a left side and a right side. Okay, so again, the top one is my odd functions. Odds are going to have opposites. Function, one side's negative, one side's positive. Evens now, where we're going to use the quadratic function to kind of base them all off of, those are going to be the same because they're going to point in the same direction. If I had a positive quadratic, I know it's an upward U, and the ends are pointing up. They're pointing towards the positive. So you can see in this function notation, the function approaches positive infinity on the left, and it approaches a positive infinity on the right. So on both sides, I had a positive. Then if I flip it, if I had a negative leading coefficient, now it's upside down and my ends are pointing downwards. So those are towards the negative infinities. And again, you can see they're the same because both sides are going downwards. Okay. So again, the hardest part is figuring out left side, right side, and where are my arrows pointing. And even if we don't have a graph, we can get a basic idea of it by looking at odds having a linear idea and evens having a quadratic idea. All right, so we're going to go through these problems together, but I'm going to do the first one with you here in this video to show you kind of how easy it is. First thing you want to do, make sure you have your function in standard form. So I do, okay? I want to know what my degree is. So in this case, the degree is 4, and I need to know my leading coefficient, which is a negative 0.5. So I have an even function, 4 is even, and I have a negative leading coefficient. So in my mind, I'm going to compare it to a quadratic that's negative. So I know it's going to have this upside down U shape. There might be stuff happening in the middle. I don't care about that stuff though. I just care what's happening on the ends. So I know it's going to have something like this on both ends happening. So what I tend to always do is I set up my last half. I know it's going to be function approaching something as x approaches negative infinity, and then the function approaches something else as x approaches positive infinity. That's your basic outline. Your end behavior is always going to be written that way. You just have to figure out, well, what is going here? And the way you do that is by noting that negative infinity is your left-hand side. So that's over here, left-hand side if I was to split it in two. And positive infinity is your right-hand side. That's over here. So when I look at this function, I want to take note, where are my arrows going? On the left-hand side, the arrow is going down. So that is a negative infinity. On the right-hand side, arrow is also going down, negative infinity. Okay, and that's all there is to it. That is your end behavior of the function, negative 0.5 x to the fourth, blah, 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 blah. Again, you only are concerned about the degree, the leading coefficient, and a general idea of what the graph looks like. You don't have to actually plot anything. Evens will always have this U shape because they're going to be based off of a quadratic, and odds are going to be a linear one. And we'll get into some practice problems with odds as we go through these together in class. Okay, and in that red bubble there, again, just says what I was just talking about. You want to visualize it. If you want to actually graph it in Desmos and see what it looks like, go for it. I'll never stop you from doing that. But to save yourself some time, if you know odds are going to be like linears, and evens are going to be like quadratics. It's going to make life a little bit easier. Okay, we're going to talk about how can we describe them from a graph as well, which we'll do in class. And the last thing for this section is talking about increasing and decreasing and a constant interval. So now this one, you need the full graph for. You need to see the full picture because now we want all that in between stuff. We already know what's happening on the ends. Now what's happening in the middles, or of the whole thing overall, I should say. So it's important that we can identify how this function is moving across the graph in total and break it down into specific intervals. A graph can move in the following ways: increasing when the y values are going up as you move left to right, decreasing when it's going down from left to right, which we looked at in the quadratic, so we're bringing those back. And then we have a new one, constant. That's if we happen to see a straight line, horizontal movement, means that it's always going to be the same value. Okay, we are always going to use x values as we identify these intervals, because we're talking about how the graph is moving from left to right. Just like when you're reading the slide, you start on the left-hand side and you move to the right-hand side. So we're always going to use our x values. And again, we did this with quadratics. In the previous chapter, we had our parabola and we knew how to find where we were increasing and where we were decreasing. And I said the easiest way to think of it is, if I'm tracing this U, my pen is going up first in this case, and then I trace it, my pen goes down. So if my pen moves up, that's an increasing motion. If my pen moves down, that's a decreasing motion. Okay, we wrote it in interval notation. So on the left-hand side, it went from negative infinity to b in this case, wherever b is. And then it decreased on the right-hand side. So from b, from that local maximum, all the way to the positive infinities. Okay, so we're going to still continue to use this interval notation. Now what's going to happen is, as our functions get bigger, we're going to have multiple areas of increasings or multiple areas of decreasings, or a combination of the two. And you'll see that in this picture, it says local maximum. That's because we're going to find some polynomials are going to have multiple maximums or multiple minimums within it. So it's local for the one we're looking at or using. Now this slide just shows a couple different functions. A constant function, it doesn't increase or it decreases, so it just stays constant, in this case from negative infinity to positive infinity. Our linear functions, in this case it's always increasing. If it was the other side, then it'd be always increasing from negative infinity to positive infinity. We have our quadratic functions, which we talked about. Cubic functions we're going to go to, it's going to all keep growing. Okay. So here's a nice bigger one. This is actually a cubic function. And I know that because of what was plugged in. But I know it's an odd function because if I look at the ends, one side's going down as the other side is going up. So again, one side's decreasing as the other side is going towards the positive. So they have opposite end behaviors, which we looked at earlier today. So because they have opposite end behaviors, I know that this is an odd degree function. Not that I need that for the intervals, but just to bring it back. So when we start looking at these larger polynomials, we need to take a look at our local maximums and minimums. So in this case, we have a local max and a local min. We have two parts, and that's okay. You can have multiple ones. You only care about the axis, and it's not technically an axis of symmetry fully, but you only care about the x value. You care where that value is turning around. Okay, so in this case, I draw my pen's going up. It's increasing till I hit this local max at -2. Then my pen turns around. It starts decreasing, going in a downward motion until I hit this local minimum at +2. And then my pen starts going back up again. So we have all these different movements as we go through it. So I have on two intervals, my pen increasing, right? So you can see over here, I'm going to write that it increases from negative infinity, because remember that's your left-hand side, to -2. So it went from negative infinity all the way to -2. I was going up, I was increasing. Then it went decreasing. I decreased. Now I decreased from -2 to +2. Again, we're only talking about x's here. From -2 to +2, my pen was going down. And then my pen turned around from +2 to positive infinity on the right-hand side. Now notice this little U right here. That means union. I'm joining the two together to talk about my increases. You can write the word and, that's fine. But mathematically, you'll see this U to show that you have multiple areas or multiple intervals. Okay, so again, I need to know on the graph a local min or a local max, so I need to be able to pull those points out, and you only use the x values when you write your intervals. So we're going to be practicing over and over again how to list our increasing and decreasing in multiple different graphs. Okay, and that's what we're going to be practicing continually throughout this lesson. One other thing that we're going to take a look at is not only where it's increasing and decreasing, but where the function is positive and negative. So I'm just going to talk about number 14 real quick before we finish up this video. So number 14, when I look at this function, I have my minimum here. If I want to draw a little axis, I can to help me split up my left side and my right side. And that looks like it's probably at about 3. I think these are going by 2s. I can see my pen's going to go down till I hit that minimum, and then my pen's going to go up. So if we just real quick do my increasing and decreasing, on the left-hand side, that's my negative infinity side, I was actually decreasing, so let's start with that. So I decreased from negative infinity to positive 3, and then my pen moves up all the way to the positive infinity side. So 3 to positive infinity. So that's your increasing and decreasing. Now for positive and negative, we're going to look at something a little different. Also, what you might see it written as is f of x is greater than 0. That just means positive. And then f of x less than 0, that means negative. So you may see either the words positive or negative, or this function notation. And what that means is, where's the graph in response to this x-axis? When it's above it, that's your positive infinity side. That's your positive function. Okay, actually not positive infinity, but that's your positive function because it goes up to positive infinity. When it's underneath my x-axis, that's the negative side, right? This is when it's greater than 0. This is when it's less than 0, the function. So what you need for those are your intercepts. So I'm going to erase this line I drew over the axis right now. So I need to know my x-intercepts for this piece. So for positive and negative, you need your x-intercepts. For increasing and decreasing, you need to know your max or min x value. Okay, so we just keep that in mind. So my x-intercepts look like they're to be a 2 and a 4. All right, this one's 2. We know that one's 4. So the graph is, excuse me, positive on this side here and this side here. So it's positive from negative infinity, we're still talking about that left-hand side, to a 2, and from 4 to positive infinity. Those were the 2 points at which my graph was above the line. Okay, if I change the color real quick to help us see, it's underneath over here. Well, it's underneath between 2 and 4. So my function is negative from 2 to 4. Again, we're always writing our x values down. The only difference is that when we talk about positives and negatives, again, we're looking at our x-intercepts, and we're talking about increasing and decreasing. We're talking about the max or min x value. Okay, so Again, we're going to go through a whole bunch more of these, practicing, finding our positive and negatives, discussing where all different functions are increasing and decreasing. And again, you need to have the graphs for this. The end behaviors we can do without a graph as long as we can visualize where our ends would be going. Okay, and then the next section we're going to learn, well, how do we actually graph these?